So, DT and VT graphs. Got 3 past paper questions here to take a look at, all 3 varying. So, looking at this first one here, we've got January 2011. Okay, so it says that a train starting from rest at station A travels on a straight horizontal track towards station B. On leaving station A, the train accelerates at a constant rate for 60 seconds until it reaches a speed of 30 meters per second at point X. The train then continues at 30 meters per second to a point Y when a constant deceleration is applied for 40 seconds, so that the speed of the train passes station B and it's 50 meters per second. The distance between stations A to B is 24 kilometers. Okay, quite a lot of information there, but we're going to need it because the first part says draw a sketch of the velocity time graph showing the motion of the train between A and B. So although it's quite a lot of information here, it's just giving it to you bit by bit. It's just showing you the journey or the motion of the train. So we just go through it bit by bit and just put that information into the graph. I've got a slight concern with this bit here, this point Y, because it's lacking a bit of information there, because it's not really telling us any times. It just says it continues at 30 meters per second. But let's take a look and see what we can do with it. So, first of all then, I'm looking at this bit here. So a constant rate for 60 seconds, right? So if we think of velocity time graph, that's telling us the time. And then it says reaches a speed of 30 meters per second. Now speed is obviously that number. Velocity is just the direction relative to the starting point. So in this case, as it's positive 30, it just tells us the graph should be going up. So in this case, speed and velocity are more or less the same thing. So, start with our y-axis. Now the x, I don't quite know how long that's going to be yet, so I'm just going to draw a line. I can definitely put an arrow there. Okay, so it needs to be going up to 30 on this bit here. Okay, because it reaches a speed of 30 meters per second. And it accelerates for a constant rate for 60 seconds. So we know we can have a point here as well for 60. 0 there. Don't forget to label your axes as well. You can drop a mark for it. And then time in seconds there. Okay then, so the first part of the journey, so that's A. And we are going there. So that's the first bit. So that's now point X. The train then continues at 30 meters per second to a point Y. Okay then, so we can put that in just as a horizontal line for now. At 30. Doesn't give us a time though. Okay, let's just do the rest of the line and we can decide what's going to go here and over here. So constant deceleration is applied for 40 seconds. So the speed of the train passes space station B is 50 meters per second, right? So that tells us that the line isn't coming to the bottom, right? It means it's going to come down to 50 because it's going to cross. It's going to go through station B at that velocity. So 15 there, it's obviously half of 30. So I'm just going to finish by sort of going down to 15 there. Okay then, so we're nearly done. We've just got to put in something for this value here and this value here, because otherwise it's not complete. We've got one there for the 60, but we need something here and we need something here, right? Otherwise we will drop a mark, and we're going to need it as well. Looking ahead to B and C, we're going to need to know what these are. So if it says that the last part is a constant deceleration for 40 seconds, we could say that this bit here is just t T for time, right? That is, it will go through station B at a time. So we know that this time here must be 40 seconds less than T. So we'll just say T minus 40. And that's about as much as we can do, really. We can't go any further with that. So let's just take a look at part B then. Part B, find the acceleration of the train and the distance travelled whilst the train was accelerating. Okay then, so acceleration is just the gradient of the graph. So if I'm looking at this bit here, this is where it was accelerating. All we're looking for is change in y, which is 30 take away 0, divided by change in x. So we've gone from 0 to 60. So that's just going to give us 0.5 meters per second squared. In terms of distance, so distance is just the area under the graph. Well, in this case, we're looking at a triangle. Height of 30, base of 60. So 30 times 60 and divide it by 2, or times it by 0.5, and that will give us 900 meters. Part C then, find the total time for the train to travel from A to B. Okay then, so the total time is going to be this value here, T. So we can use the fact that the distance between the stations is 24 kilometers, right? And the reason that's important, one, they've given it to us, it probably means something, but also because this T can be used as part of the shapes we see under the graph, right? We've got a trapezium there, a rectangle there, and a triangle there, which we've already found the area of. So with that knowledge in mind, and the fact that it's equal to 24 kilometers, we can find out T that way. So, part C then. So if I'm looking at the area, first part, we know that's 900. So we'll take that, 900 meters. This second bit here though, right? So as it's a rectangle, it's just going to be length times width. So the width is clearly 30. But then we're timesing it by the length. Well, the length we don't know, but we know that up to that point is 60, and then up to that we're saying is T minus 40. So if I wanted to work out this length here, I would take away this bit from the whole line. So we can say T minus 40 take away 60. Then the last bit we've got is a trapezium. So our parallel lines are there. One is 30, one is 15. So we can say plus 30 plus 15. Let's put that in brackets because then we need to multiply it by the height. Although we've got T minus 40 and T, we do know that that period of time is 40. And then don't forget to divide by 2. There we are. Only thing left to do now is say that that is equal to 24,000. All right, because that is 24 kilometers in meters. Why am I doing it in meters? Because that's in meters. All right, we found that in meters, which means it's all in meters. So that's why we need that value there. Right, and then it's just a case of sorting all this out, rearranging or balancing to find out what T is. So 900 plus, right, so T take away 40, take away 60. Well, that's going to be T take away 100. 30 times T is 30T. 30 times minus 100 is minus 3,000. Here, 30 plus 15 is 45, times 40 is something, divided by 2, I'm just going to tell you, is 900. And then that is equal to 24,000. So sorting all that out is going to give us 30T equals 25,200, and then dividing both sides by 30, or just dividing that by 30, gives you 840 seconds.